Hi, everybody. Welcome to episode 4 in Adventures in Anatomy and Physiology. Today, we're going to be talking about my absolute favorite system in the body, which is the renal system. So, that's the system that has the kidney in it, the ureter, the bladder, but it also has the blood that's involved in it. And this is a system, especially the kidney as an organ, is very misunderstood. A lot of people think that it has one job, and that's to make urine or to make pee, but that's actually not true. It has so many other jobs, and it's a very, very important organ in our body. So, the first thing that we're going to cover here, because it's just as important as everything else, is where exactly are our kidneys located? So, our kidneys, right here, are going to be located actually in our abdomen. So, where our other digestive organs are, so that would be our stomach and our intestines and our colon, are all going to be located in our abdomen. But the kidneys specifically are going to be located on the back side of our abdomen. So imagine them instead of being on the front side, when you have like a stomach ache and you're really pointing to your front side, the kidneys are going to be actually on your back. So if you have pain in your kidneys, you're going to feel it in your back instead of at your front. So your kidneys are actually located on the back next to your spine, which is kind of hidden here, but it would be around where the white lines that I drew. So they're actually located very close to your spine that we spoke about in episode 1. So now we're just going to go over some quick anatomy of the outside of the kidney. And first, we could see that the kidney, just like the bean, that the bean is named after the kidney, it has this kidney bean shape to it. And the main part of the kidney that we could see right here is called the renal capsule. So renal just is any word that refers to the kidney, and capsule is almost like an outside wall holding the kidney, the inside of the kidney together. And it gives this shiny look to the kidney. On top of the kidney, we have this adrenal gland. And this is a very important structure that we're not going to talk about today because it's not really part of the renal system, but it has a very, very important effect in the body, and we'll cover it in a whole separate video. But just know from the name adrenal, ad meaning that it's on top, and renal again meaning that it's referring to the kidney. So that's where it gets its name, adrenal gland. The other structure, or I guess landmark that we could see here, is this kind of dent in our kidney. And this dent is going to be called our renal hilum. So just like we had a hilum in the lungs, our renal hilum is going to be where the structures that need to enter into the inside of the kidney are going to enter through. So this is going to be our door into the kidney. And what's going to enter through our door? We have our renal artery. And if we remember, arteries are things that bring blood away from the heart. So we're going to be bringing blood into our kidney. We have our renal vein that's going to be bringing blood back to the heart. So it's going to be bringing blood out of our kidney. And we also have this structure down here called our ureter. And our ureter is what's going to bring our urine, or what's commonly called pee, down into our bladder so it could be removed from our body. Now we could take a closer look at the inside of our kidney, and it's quite a complex organ. And remember, we do have two of these. And what we could see is, again, our renal capsule, just as a reminder, that's the outside of the kidney. Again, we have our renal artery here, our renal vein here, and again, we could see our ureter. So just a reminder what these structures look like, especially the ureter here, you could see how it's actually being formed. Now that I created a picture, opened up so we could see the inside of the kidney. So let's follow how the ureter is formed. So first, we have these little dents, and I'm gonna just attach two of them so you could understand these little dents. And these little dents are going to be the collection places of where the urine, or again, the pee is going to first enter into the kidney from its location of creation. So this is going to be called our minor calyx, and it's quite an interesting name to say calyx, It's spelled quite weirdly, but that's what it's called. And then these bigger collection areas are called major calyx. Or in this case, since I put two, it would be a major or major calyces. But for now, we're just going to stick to the term that I put on the video. So what exactly are this minor and major calyx? So these are going to be the first collection sites for urine or for pee. And if you imagine the creation of urine like going down a slide, because after all it is liquid, it's going to start at the minor calyx, go down into the major calyx, and then we're going to reach this bigger slide, and this bigger slide is called our renal pelvis. So pelvis because of its triangular shape, and this is going to be the major collection point. So this is where it's going to be stored for a very small amount of time before it all goes down and keeps going down the ureter until we're going to reach down into our bladder, which is where our urine or our pee is stored for a long amount of time. The other things that we could see here are, this is going to be a little bit tricky to show, but we have little branches of our renal artery. So I'm just going to write small artery branches. And we also have the same here for our vein. So small vein branches. So this is the continuation of our renal artery and our renal vein going deeper inside our kidney and breaking up into smaller branches, right? It's not going to stay as one big branch. We want to break up all the branches around the inside of the kidney. What we could also see is that we have two layers of the kidney. We have these triangle looking layers, and we also have this light pink layer that's surrounding these triangle layers. So this light pink layer is called our renal cortex. And if we think of the word cortex coming from the Latin word for crown, which is corona, this is going to be the most outer edge of the inside of the kidney. So if we think of it crowning all these triangles, it's going to come all the way on the outside edge of our kidney. It's going to be our renal cortex. And then these triangles are the renal medulla. And medulla just means middle. So it's going to be the middle layer of the inside of our kidney is going to be called the renal medulla. And in this case, these triangles actually are called pyramids. And that's a pretty easy name to remember because they are pyramid shaped. So it's easy to just remember that in the renal medulla, these triangles that we have, so our middle layer of our inside kidney, are called renal pyramids. So before we go super deep into how the kidney actually works and what the kidney actually does, we have this structure here called the nephron. And this nephron is a very complex and very small structure. So this is something that we haven't yet spoken about in my videos, but now we're going to go to things that are invisible to the naked eye. This is things that we need to zoom in to look at. We need a microscope. We need a really strong magnifying tool to be able to look at this nephron. And these nephrons, if you remember the two layers that we spoke about, is going to be split like this. It's going to be, most of it is going to be in the renal cortex layer, so that light pink top layer. And then the bottom layer, mostly this loop down here and this tube here, are going to be inside of our renal medulla, so our middle layer. And this structure, the nephron, these series of tubes, and you'll see this artery coming down here, are going to be what's responsible for actually making the urine or the pee. By now that I'll give you a little bit of a hint of what the kidney actually does, it's going to filter and clean our blood. And all the dirty parts in our blood are what's going to end up making our pee. But before we talk more about the nephron, we're going to actually talk about what is blood. Because to know how we clean blood, we need to know what blood is. So, what is blood exactly? So, blood, as we know, is the liquid, or sometimes it could be more solid, but it is a liquid that flows through our arteries and our veins, as we discussed in previous videos. And what exactly is blood when you look at what's inside this liquid? So if you leave blood by itself, it will eventually split. Imagine like if you ever do this experiment at home, when you have water and oil, if you leave them long enough, they'll actually split from each other. Even if you shake them really, really, really hard to mix, they'll split from each other because they don't want to be together. There's something forcing them to be together, and that's the movement, right? So if you shake it and they mix, and then you leave it and they separate, that means that they never wanted to be together in the first place. They did not want to mix, they were forced to. So it's the same with blood. If you leave blood long enough, it'll split into these three layers that I've shown here. So we have our top layer, our middle layer, and our bottom layer. So our bottom layer is the layer that most people know, and that's going to be our red blood cells. So our red blood cells is what actually makes blood red. So it's quite important. And it's also going to be what's going to carry our oxygen throughout our blood to be given to all the organs and the tissues and the muscles in our body. So when I spoke about in the episode about the heart, that when we look at the heart, its job is to pump blood around the body so oxygen could be moved around the body. This oxygen is going to be attached to these red blood cells. So remember, this layer has red blood cells in it, which is what makes blood red. And it also is these red blood cells that will carry the oxygen around the body. So our second layer, our middle layer, is going to have something that's less spoken about, and that's going to be our white blood cells, which are super important, but they also have our platelets. So our white blood cells are going to be the cells that are involved in our immune system. So when you have a cold or you have an infection or you're sick, these white blood cells are going to be the soldiers in the body that are going to fight off that infection or that sickness. So they're super, super important to the body. And the reason that they're found in our blood is because they need to be able to travel all over the body to deal with these infections and these sicknesses. So it's perfect for them to join in the liquid that's found everywhere in the body. Platelets are also super important, but are very, very, very small. These platelets are what's going to be responsible from keeping you from clotting. So, and I'll write that word down. So, what exactly is clotting, or why are these important? So, if we think about, let's say we get a paper cut. Why don't we bleed forever? Why aren't we just, why isn't the liquid of blood just coming out of our finger after a paper cut forever and ever and ever? Why do we stop bleeding? And that's because of clotting. These platelets are going to stick to the cut and close it so we stop bleeding. That's what these platelets do, is that they stop permanent bleeding. They close up our cuts or our what's called a wound, or any damage to the skin that would cause bleeding is going to be stopped by our platelets. So they are super, super, super important. The top layer is probably the layer that people are the least familiar with. And this layer is going to be called our plasma layer. So this plasma layer is actually going to be mostly water. It's probably going to be close to 95 or 90, even maybe 98% water. It's mostly water. But in that water, we also have things that are incredibly, incredibly, incredibly important. And these are going to be our ions. And maybe people don't really think about this a lot, or it hasn't really been taught in any way. But whenever you have, let's say, your parents or a doctor, or you find a YouTube video online that tells you, oh, we need to drink more, you need to eat more salt, you need to drink more milk so you could have minerals, and all these minerals and all these salts are all considered ions that are going to be floating in the water that's in our plasma layer. So, for example, the most common ones, the ones we're going to talk about today, are sodium. And I know it's confusing that it's Na plus or it's Na and not SO, but just think about it as sodium. There's hydrogen, which is part of the thing that makes up water. There's also potassium, which again, I know it's weird that it's K and not P. We also have one other thing that we're going to talk about that's not an ion, but it's going to be within this layer. We also have these little balls here called proteins. So we're going to have proteins in our blood, and these proteins are a little bit bigger than the ions. And we're not really going to talk about them today because they have a very, very important and complex function, and we'll be looking at them in a separate video. But just to know for our plasma layer, our top layer, it's going to be water and these ions slash minerals that are going to be floating in our water that are super important to our body. Now, if we look at exactly what blood looks like inside of, for example, an artery here. So imagine this is the tube of an artery, and inside we have here our red blood cells, remember, that are going to carry the oxygen. We have our white blood cells here, our proteins, and also we have all these little circles here that I drew that are going to be those ions and minerals that are floating in our blood. And now we're going to talk about this concept of filtration. So, how are all these things going to leave our blood to get inside of our kidney? How are they going to go from being blood? All these bad things are going to go from being blood to becoming into our urine or our pee. And how is that going to happen? It's going to happen through these little holes inside of our arteries. And these holes inside of very, very, very small, I'll write that, very, very, very small arteries, not the big ones. So not our aorta or the ones that we previously spoke about, like the renal artery, but those really, really, really small branches of arteries are going to have these little holes in them where very, very small things like the minerals, so our sodium, our potassium, our hydrogen, and even our water, so water is H2O, will be able to leave these little holes. But what will not be able to leave these little holes are the red blood cells, are the white blood cells, and our proteins are going to stay all inside of our blood. They will not leave into our into to becoming our urine. And how do we know that? Well, most of the time, and I know maybe this is a little bit gross to think about, when we look at the color of pee, it's not red. Why? Because we do not have red blood cells in there. And that's a good thing. We don't want to lose our red blood cells. So the only things that are going to leave and get filtered out of the blood are going to be really, really small things. And those are our little ions, so our salts and our minerals. So now that we've covered that, we're ready to cover the nephron. And the nephron is, imagine the small filtration center in our kidney. So first, we're going to go over what exactly does the nephron do? Why is the reason that we're cleaning blood and that all the other things that we're doing within our nephron? So I said at the beginning of the video that the kidney is very misunderstood. People think that the only thing the kidney does is make urine, but that is not the case. Urine is formed as a result of the other functions of the kidney. And what exactly are those functions? So I'll write them here. So one of the major functions of the kidney is blood pressure. So I spoke about blood pressure in the heart episode. So blood pressure is very, very, very important. Maybe you know people in your life that have high blood pressure or low blood pressure, but blood pressure is going to be um, controlled by our kidney because blood pressure, a big part of blood pressure, is actually going to lead into our second function, which is fluid, or I'll write liquid so it's more understandable. Fluid and liquid maintenance. So maintenance is basically a word to say that we're keeping track of what's going on. So fluid and liquid maintenance in the body. And how does that control blood pressure? So remember how when I was talking in filtration that water and little minerals and these salts could leave our blood. That's how we control blood pressure. So if our blood pressure is too high, we could make water leave our blood and make the blood pressure go down. So that's one of the biggest functions of our kidney. Or we could do the opposite and we could add water back into our blood and we could make water stay in our blood and higher our blood pressure if our blood pressure is too low. Another function of our kidney, and maybe this is a very new topic to you, is pH balance. So maybe you've seen pH early on in your life, maybe in high school or at the end of elementary school, or even later on in your career. So pH is the best example, and the way people learn it is we think about things that are acids and things that are bases. So acids are things like lemon juice, stomach acid, vinegar, and bases are things like soap or bleach, um, or baking soda. And basically, the kidney's job is to make sure that the blood or the liquids in our body are all at their proper pH, and especially the blood. So the kidney's job is to make sure that this ion right here, hydrogen, is always at a good level so that we always have the proper pH in the blood. And the last function, the main function that people know, is waste removal. So this waste removal is what most people think of when they think of the kidney, is this creation of urine. That is us removing waste from our blood. So now that we've looked at the functions of the kidney, or the nephron in this case, now we're going to look at how it works. So remember, this is a very, 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 very small artery that we're going down. A very, very, very small artery, not a big artery. I know that it's zoomed in, but imagine this as an incredibly, incredibly small branch of an artery. And we're going to reach this junction here, and this junction is going to have a weird name. It's going to be called the glomerulus. And I know that that's an interesting name, and it's a little bit hard to pronounce even for me. But this glomerulus is going to be all of these branches, or this curled up like a ball of yarn, branches of this small artery coming in. And basically, what's going to happen is, the best way I could give this as an explanation is that, do you see how this artery is actually bigger in size than this artery here? So, why is that important? So, imagine a highway. So I'll draw a highway like this. So we'll have our street, and then all of a sudden, the highway is going to shrink. The street is going to shrink into one singular lane for cars to pass. So all the cars coming here are going to have so much room, and then all of a sudden, they're all going to have to go down one street. So there's going to be so much traffic at that one little place where everything is shrinking. Now imagine that there's holes, that I open little windows for cars to leave if they wanted to, where it becomes small. How many cars do you think are going to leave? The answer is a lot of cars are going to want to leave because they're not going to want to have to deal with how much traffic they're going to encounter trying to get into that small street. So that's the same thing that's going to happen at this glomerulus, is that this big artery, or small, super small artery that's bigger than the other, so I'll write even smaller artery. Everything in the blood, if you remember that there's little holes inside of our very, very small arteries, everything is going to want to leave at the glomerulus. So all the little salts and minerals in our very, very small artery coming down here, everything is going to leave into these little pockets and leave our small artery. So that's going to be step one. So imagine that everything in this small artery, except right the red and white blood cells, and our platelets and our proteins, our bigger little structures, are not going to leave, but everything else is going to leave, and it's going to end up going through this first tube here, and that's going to be step one. We already completed, and that's filtration. So we're going to filter out everything in our blood. So a good thing to think about is that we're not going to filter out only the bad things. We're going to filter out everything. Everything is going to come out. And then later on, how the kidney works is that we're going to put the good things back into the blood instead of only removing the bad things. So this first tube that I just drew a white line through that we're going to go through is going to have an interesting name. It's going to be called the proximal convoluted tubule. So another long name to remember. A lot of the names in the nephron or in the kidney are very complex, but where the name comes from, proximal convoluted tubule, comes from the word proximal, which means close, convoluted meaning complicated, and tubule just being tube. So it's a close tube, right? We're close to our glomerulus, and it's very complicated. There's a lot of winds and twists and weird pathing going through this tube. And once we get down here into this loop, that if you remember what I said earlier, is actually going to be part of our the medulla part of our kidney. So it's going to be the deeper middle layer of our kidney. We're going to have here our loop of Henle. So this loop of Henle is where we're going to start to actually bring the two most important things back into our blood. So that's going to be our water and our sodium. So here it's going to be water's coming back in, and here sodium is going to come back in. So remember how I said that everything comes out, even the bad, even the good, and then only the good comes back in? So water and sodium, we need to come back in. And going back to our proximal convoluted tubule, we're also going to have things coming back in, but at a way smaller scale compared to the loop of Henle. Now we've reached this second tube that's further away from our glomerulus, so our filtration site, and it's going to be called our distal convoluted tubule. And distal meaning far away, so distanced, right? The word distance. And convoluted again meaning confusing or complicated, and tubule being tube. And this is where we're going to have our almost last chance for bringing things back in the blood. So this is going to be where if the body says like, hey, we're missing this in our blood, this is going to come through into the blood back from our distal convoluted tubule. Lastly, we have this last structure here, and this is going to be called our collecting tubule. So tubule again being tube and collecting, we all know the word collecting. So this is actually going to be the place where we say once that the liquid enters our collecting tubule from the distal convoluted tubule, now we're saying that it has became or it is now urine or it's pee. And this collecting tubule is going to connect the nephron into, if you remember from the anatomy of the inside of the kidney that I covered a bit ago, into our minor calyx, which will then connect to our major calyx, our renal pelvis, and then to our ureter. So this collecting tubule is the first step of collecting urine towards the outside of the body. So I know that last drawing, it was very complicated compared to the things that I usually do. There was a lot going on, but now I'm going to try to simplify it. So we're going to talk about what exactly is reabsorption. So reabsorption is what happens in our proximal convoluted tubule. So proximal convoluted tubule, our PCT, and our loop of Henle, and also in our DCT, our distal convoluted tubule. So remember, everything now is inside of our tubes in our nephron. Everything has left the blood. All the small things have left. So our water is here, our salts are here, and our minerals are all floating in this liquid that's going to become pee eventually. But how are we going to bring the things that we want back in? And that's going to be done through reabsorption. So this here is a sodium. So let's say the body says, hey, we're low in sodium. Let's bring the sodium back into the blood. So we're going to have these blood vessels that I drew on each outer wall. So that's going to be the red, is going to be these blood vessels, right? Branches of small arteries that are going to be on top and on the bottom of our proximal convoluted tubule or any of the other tubules. That's going to let the minerals or the salts come back in. So let's say our sodium comes back into the blood, and then the body says, hey, I want some potassium back in the blood. So potassium is going to come back into the blood. And it could be the same for our hydrogen. So we could have hydrogen come back into the blood. We could have this water here come back into the blood. But what we cannot have and will not happen is this yellow one here with U that I haven't spoken about yet. And this is urea. Urea is what gives urine its name, urine. And it's the reason that urine actually has a yellow color, or pee is yellow, is because of urea. Urea is the waste of the body. It's the garbage of the body. So when there's urea in our liquid that's inside of our tubules in the nephron or in the kidney, that's because that's the garbage or the waste of the body. And that's what we're trying to get rid of and what we're going to keep inside this tubule. It will not come back into the blood. It will stay there so it could be eliminated. So lastly, once we've gone through the process of cleaning our blood, bringing all the good stuff back in that the body needs, and letting our urea continue on through all of our tubules and then through our collecting tubule, and then down right to our minor calyx, then our major calyx, then our renal pelvis, and then to our ureter, which is right here. It's going to continue all the way down until this structure here. And this structure is our bladder. And our bladder, sorry, I'm just going to write that bigger. That was a little too small, is our bladder. So our bladder is going to be the storage. What's going to keep our urine, our pee, until we go to the bathroom, right? The body decides when it's time to go to the bathroom, and it'll tell you. The brain will tell you, hey, I have to pee. Let's go to the bathroom. Let's go pee. And then from the bladder, we're going to have another tube called the urethra. And then through the urethra is where the pee is going to leave our body. And that's how we get the waste of our body out of our body while also cleaning the blood and going through the other functions that I said, right? So having good blood pressure control, having good pH control, and having good liquid control in the body. So I know that was a more complex episode today, but I hope you guys still enjoyed it, and I hope you guys could appreciate how complex the kidneys actually are. When people think about the kidneys, they think of them as so simple, but they're actually very, very, very complex. And there's so many things that I did not talk about that if I wanted to, I could make maybe 10 more videos about. But I hope you guys enjoyed this video, and I hope you guys enjoyed how complex it was. And maybe in the future, I'll make some more complex videos. But thank you for watching, and I hope you guys enjoyed, and I'll see you in episode 5.